we're going to do is, with our rational functions, we are going to find vertical asymptotes. Now, the vertical asymptotes are the easiest to find, and what you're going to do is, first of all, if you have removable discontinuities, you want to remove those. The next thing you want to do is set your denominator equal to 0 and solve. And everywhere that you get a value, you have a vertical asymptote. All right, so if you take a look at this particular function right here, what we would do is take x minus 2, x minus 3, equal to 0, which means x equals 2 and x equals 3, right? Okay, those are actually your vertical asymptotes. So I want you to see what this looks like. So we'll go to Desmos here and we'll plot this on a graph so you can just see that that is the case. Okay, so here you can see this graph. Let me turn the little light off so we don't have so much glare there. You see how we essentially have a vertical asymptote right here at 2 and at 3, and I'm kind of curious what goes on up here. Like, I don't know how far I would have to go to see if there's anything in between. I mean, there should be, but I'm going to have to totally reset this at some point here. Maybe it's the other way. Let's see. Sorry, guys. We want to see what this looks like. There it is!
Oh my gosh, it was right there.
Yep, there it is. There's the rest of it. And that actually goes between 2 and 3. So see how this actually has 2 discontinuities, non-removable, and has multiple parts, 3 parts, 1, 2, 3 parts of the graph. This is rational functions for you.
We were scrolling so high and it was just right there.
And it was right there, I know. So silly. Okay. Let's flip the page and do it again. Okay, so the first thing that you want to do is, if you have removable discontinuities, cancel those out, okay? Because if they're removable, you're not going to get an asymptote right there. Then take what's left of your denominator, set it equal to 0, and solve. Vertical asymptote. You want to see what that looks like?
Sure.
This is going to, right, this will be interesting. So let me put this one on here. Whoops. Okay, now this does do something interesting. Would you agree, here's our graph, but we have a removable discontinuity at x equals 2, right? Okay, so really at x equals 2, which is right here on your graph, you should have a hole. But the program isn't going to put it there for you. But you do. You have a hole right here.
I don't think put it there.
I don't know why they don't. You can write to Desmos and ask them why they don't do that.
I will.
Okay. But they don't. And there should be a little hole right there. There should be. Okay. So, vertical asymptote for the third example. Set your denominator equal to 0 and solve. There it is. Oh, hang on. This factors. X plus 1, X minus 1, right? Over X plus 1. Cancels. Do we have any vertical asymptotes? No vertical asymptotes.
This is the easiest thing we've done in a month.
Okay, next thing we're going to do is horizontal asymptotes. This is a little bit more complicated. Okay? So draw a nice big circle around this box in your notes. This guy is going to be key. Alright, so we'll start right there. This is going to be key. Alright, when looking for horizontal asymptotes, first thing, you want to write your numerator and denominator as polynomials in standard form to do this, okay? And you need to look at a couple of things, and one of those things is the degree of the numerator and denominator. And if you recall, that is going to be the power of your leading term. So if you have a quadratic up there, it's a second degree polynomial, right? And if it's like, for example, would you agree here, this is a degree 1 polynomial. This is a degree 2 polynomial. This is degree 1, this is degree 1. If we look down here, this is degree 2 and degree 1. You need to know that when you look at it. The other thing you need to look at is your leading coefficient. Would you agree this is 2, this is 1. This is 1, this is 1. This is 1, this is 2. So let's line up a couple of facts. First of all, if the degree of, let's see, the degree of the numerator, let's underline this, is m, the degree of the denominator is n. If m is less than n, the graph has no horizontal asymptotes, or the graph has a horizontal asymptote at y equals 0. So let's look for m, degree of the numerator is less than the denominator, right? Yes. Right here? Degree is 1, degree is 2. M is less than n, right? Alright, so there is a horizontal asymptote. At y equals 0. Okay? Now, if the numerator has a higher degree than the denominator, there is no horizontal asymptote. Would you agree that's the case here? M, which is the numerator, has a higher degree than the bottom, right? So this one, m is greater than n, no horizontal asymptotes. Next thing, if m equals n, so do you see how this is a first degree and that's a first degree? M equals n. All right, so let's proceed. Where the horizontal asymptote is a over b, where a is the coefficient of the numerator and b is the coefficient in the denominator. Would you agree? Coefficient, coefficient, right? So we do have a horizontal asymptote. So first of all, this is an m equals n situation. Horizontal asymptote. At y equals 2 over 1 which is y equals 2. We're going to practice doing this.
Wait, why is it over 1?
Because the coefficient down here is 1.
Oh,
That coefficient is 2, this coefficient is 1.
okay.
So 2 over 1, which is 2.
Okay, thank you.
Yes. Okay. Last page. Let us do this. First of all, we've got to graph these things. I want to write this in 2 ways. One is in standard form and one is in factored form. So let's write this next to it in factored form, right? Okay, numerator, how would this factor?
3
X minus 3, x plus 4. Go to the denominator. Wouldn't you agree this is x plus 2, x minus 2? Do we have any removable discontinuities here? No removable discontinuities. So we need to find our vertical asymptotes. So vertical asymptotes. Take your denominator and set it equal to 0. So x plus 2, x minus 2 equals 0. This is going to give you x equals negative 2 and x equals 2. Fair enough? Let's draw those in. Hopefully I've given us enough graph paper here to draw these graphs in here. We'll see. Okay, next thing we're going to do, just for kicks, let's do domain. Would you agree? All real numbers except x not equal to 2, x not equal to negative 2, right? Fair enough? Okay, horizontal asymptote. All right, what's your m value here? The degree of the numerator.
X squared.
Right, so it's a second degree, right? So when you think about that, your m is 2, right? What's n? The degree of the denominator, which is what?
2.
2. So n equals 2. So this is an m equals n situation. So in that case, y equals a over b. A is the coefficient of the leading term in the numerator, which is 1, right there. And b is the coefficient of the leading term, 1. So, in other words, what we have is the line y equals 1, which is going to give us that beauty. Whoops, I didn't draw it in red. What a pooper. I'm going to redraw it. It's going to be purple, but it's better than blue. Okay, now it's just black. That's a bummer. Okay. So there's our horizontal asymptote. You know what we can do? So we know our graph is somewhere in this little continuum here. We've got to figure out where it is. Let's find a y-intercept, which is the point 0 something. So I would have negative 3, positive 4, 2, and negative 2, which gives me negative 12 over negative 4, which is positive 3, right? All I did was plug 0 in. My function right here, plug 0 in. So 0, 3. So there we are. Now, this is very helpful to me. And the reason why, I now know this is going to go up in this section. It's not going to go the other way because I have an asymptote down there. So this is going to go like this, flat out. There's no other choice. All right? That's what? All right. Now, This also means that the other parts of our graph are going to be here and here,
I didn't know that.
because they're not going to be up here and over here. It crisscrosses.
Oh.
So, I guess it's not necessarily always true. Once you get some big ones, not necessarily true. So anyways, here's what we can do. We know we don't have any graph right here. So let's do this. Let's find some x-intercepts. And remember, with our x-intercepts, we're going to set the y equal to 0. When we do that, you set the numerator equal to 0. So this is x minus 3, x plus 4 equal to 0, which gives us x equal 3 and x equals 4. So 3, 0, whoops, and negative 4, and negative 4, 0. So 3, 0, negative 4, 0. So now I find that I was correct. This is going to look like this. And you can find more points if you want. Just pick some x values, plug them in your calculator, and find some y values. This is going to go down here like this, and off like this. Pretty cool. Okay, let's do another one. All right, first of all, let's factor this. How do I factor? The numerator I don't have to worry about. Let's factor that denominator.
X minus 5, x minus 1.
Yes. Okay, so let's find our vertical asymptotes. Who can tell me what we need to do?
Set
The denominator to 0.
Yep. So I've got x minus 5, x minus 1 equals 0, gives me x equals 5, x equals 1. So, get the red pen out. There we go. X equals 5 and x equals 1. Let's scooch this up here a little bit. Okay. So, our domain, all real numbers except x cannot equal 5, x cannot equal 1. Fair enough? Okay. Horizontal asymptote. Okay, what is our M?
1.
You're right. What is our N?
2.
2. So this is an M is less than N situation. Go back to this lovely table over here. So we have a horizontal asymptote at y equals 0. So at y equals 0. So let's go ahead and draw that one in. So guess what? We're not going to have an x-intercept because we've got an asymptote right on the x-axis. There won't be any x-intercepts. We can do a y-intercept if we want. So a y-intercept, 0. And let's put this in. Plug in 0 in place of x. So I've got 3 over negative 5 times negative 1 gives me 3/5. So 0, 3/5. So maybe right about there. Seem reasonable? We got to find some points so we can figure out where this thing is at. Okay, I know it's up here. That's not going to be difficult to find, but I need to know where it is in here. So how about 3? Let's plug in x equals 3. So would you agree that gives me 6, a negative 2, and a 2? Does that make sense? which is going to give me negative 6 over 4, which is negative 3 halves. All good? Okay, so 3, and then we have negative 3 halves, which is right there. Well, it's not going to cross any asymptotes, so here's what this is going to do. It's going to go like this, because we don't cross asymptotes. And it's going to go like this. Let's find out what's happening at 6. So at the top will be 9, this will be 1, and this will be 5. So this is 9/5, which I want to say is about, what, 1.8? So 6 is 1.8, so right there. And you can do as many points as you need to do until you feel comfortable about this, but I'm feeling comfortable that we've got something that looks a little bit like this.